All right, let's look here. It says, I got the triangles are congruent. Guys, I'm missing tick marks. What is the test expecting you to do? Put it in there. Okay, so now I got, that's congruent to that. So there's a side, angle, side. So come down here, side, angle, side, D over there. Don't get tricked by this one because it's a right triangle in HL. Remember, what does the H stand for? Hypotenuse. What's the L stand for? Leg. Guys, the best way to do number 42 here is just write out the whole formula. Okay, so the formula for a combination is n factorial over, so that's 9 minus 5 is 4, 5 factorial. Yeah, on this you can't use a graphic calculator. Yeah, that's what I'm saying. So now I got 9 times 8 times 7 times 6 times, no, I stopped and canceled out 5 factorial with this. Okay, the problem though is you still got another 4 times 3 times 2 times 1. Now this is where I lose some of you because you get the idea that you all have to do it the same way. Guys, some of you can go 4 times 2 cancels out 8. I like 3 times 2 cancels out 6. 8 goes in there 2. It's the same thing. Doesn't matter what you do. I could go 4 times 2 is 8 and then be left with 2 over there. Yeah, you got to cancel stuff out because you're reducing fractions. So now I got either, watch, either I got 7 times 18, 14 times, guys, you just got to multiply the things together. It really doesn't matter. So 18 times 7, 70 and 56 is 126. If I look down here and it's D. Consecutive angles. What's consecutive? One right after the other. So the consecutive angles of a parallelogram, okay, that's congruent. Opposite sides are congruent. Opposite angles are congruent. But consecutive angles, not congruent. Supplementary. 180. While we're here, let's go ahead and get the word from last semester. Last semester, the big word that we learned instead of supplementary was complementary, which means they add together to give you 90. The 360 that y'all are using is the sum of exterior angles. Okay, your town, let's stay on task here, please. The town is holding local election. The town set up 3 polling stations around an area formed by a triangle. They decide to meet at the Circumcenter. Here's a name that, this is what you asked me about right here, the Circumcenter. The Circumcenter is equidistant from the 3 angles of a triangle formed by the point. Really, it's not necessarily the angles, but the vertices. The vertices. Okay, the angle is made up of 3 vertices, but they're trying to get you together to understand it comes at the same distance from each polling station. So regardless of where you leave from, it'll be the same place. Now, that is something that I have a little experience with because I've been I worked as a poll worker, and you just volunteer for it. But in our county, in our little area here, a lot of times we do our voting because of where I live at Mountain Park Library. You may have parents, or you obviously do have parents, but they may vote somewhere else. But my point is, in our situation, they don't use the most convenient place for everybody like the Circumcenter. They use the county seat, which is in Lawrenceville. There's a store over there in Lawrenceville. It used to be a Walmart, kind of back behind some things over in Lawrenceville. And anyways, what must be true in order for by side angle side? Well, if I've got a side, I know these two angles are vertical angles. So I need to somehow or another, if I'm going to get side angle side, can I get any side? No, it's got to be the one that makes up that angle. So the one that makes up that angle is AE and CE. So 45 is A. Here's the word we talked about. State a counterexample. What's a counterexample do to a statement? False. A flower is a small living thing with bright colors. Some flowers have petals, many birds have bright colors, some flowers are large, flowers also have a stem. Which would be a counterexample to make a flower is a small living thing with bright colors. It's B, many birds also have bright colors. You see what it's saying? But just because it has bright colors doesn't make it a flower. So B would be a counterexample. Midpoint, how do you find the midpoint? Half, add them together. 6 divided by 2 is 3. Add them together. 4 divided by 2 is 2. So it's 3, 2. Guys, this is not the one that concerns me. The question on a final exam that concerns me is when they give you one of the endpoints and the midpoint. We sometimes don't necessarily understand how to do that. Look, if I gave you 9 was 1 point, 9, 1 was 1 point, the midpoint was 3, 2, and asked you for this other point over here. Guys, do you use a different formula? No, same formula. Now I just go 9 plus x2, anybody? Divided by 2 equals 3. Now, what's the first step to start that problem out? Cross multiply. So I'd have 9 plus x2 equals 6. So what's my second x equal to? Come on. Say it right, not 3. Negative 3. Look, it says it right there. If I give you your first endpoint and one of the midpoint, guys, use the same exact formula. So 1 plus y2 divided by 2 now is going to be equal to 2. When I cross multiply, 1 plus y2 equals 4. y2 is indeed 1. 48, the diagonals of a parallelogram are always bisect each other. 49, sum of the interior angles. Okay, this is exterior angles. My question is not related to this. My first question is not related to this. Okay, again, guys, answer my first question. What's the sum of the interior angles of this figure? There you go. N minus 2 times 180. Okay? Now, that's not what you use for this problem. Okay? N minus 2 times 180 is what you use when they want to know the interior angles. Notice these are the exterior angles. Since these are the exterior angles, you're going to have to take 64 and add 56. You're going to have to add 77. You're going to have to add 38. I'm going to have to add x. I'm going to have to add x and get 2x plus whatever those add up to be. I got a calculator handy real quick. 64 plus 56 plus 77. I got 258. What do I set them up equal to? 3 something. 360. Okay, so I subtract that from 360. That gives me 102. If 2x equals 102,
it's 51.
what answer is 51?
D.
All right, last one here, then we'll take a break. Which links allow you to construct a triangle? Guys, again, I'm very concerned that we think that I just sit up here and I just make things up and they don't have to be connected with one another. They don't have to have any kind of relationship. Guys, they do. 7, 2, and 2. I can write 7, 2, and 2 all day long. But 7, 2, and 2 are not sides of a triangle. Okay? 6, 8, and 10. I'm just going over to C. B doesn't work because 4 plus 1 gives me 5, and that's not greater than 9. 6, 8, 10. If I really knew what I was doing right here, I could start out and probably would have went straight to 6, 8, and 10 because 6, 8, and 10 is part of a Pythagorean triple. Does anybody know which Pythagorean triple? 3, 4, 5. That's right. This doesn't work either. This is just like a 3, 4, 5. 6 plus 8 is 14. 8 plus 10 is greater than 6. 10 plus 6 is greater than 8. But this comes from a 3, 4, 5 triangle. It's kind of cool that that happened right here today because a few hours from now, or actually more than that, we're going to line up the football field. We're going to do the big field, the game field, because we have a scrimmage tomorrow night. And when we line off the game field, the first thing that we got to do is we got to make sure the corners are square. If those corners aren't square, the field gets in there off at an angle, and no, it's free. And so anyway, the way we do it is by going 80 across the field, 60 down the sideline, and 100 across the diagonal. And that 80, 60, 100 triangle, make sure that that angle in the corner is a 90-degree angle. Then once we got that right, we take off. Now, that's the way we originally did it. Now what we have is a big nail right there that we find we just find it, and then we just measure that angle like a 3, 4, 5. We just measure a little short something to make sure. Does anybody remember any other Pythagorean triples? 3, 4, 5? Something 15. No. 12, 13, and something. What's 169 minus 44? 25. So what is it? 5, 12, 13. Let's go back to this 15 one. I want to see if anybody remembers that one. 8 squared. 8 squared was 64. What would you say, 15? What's 64? 225 minus 64. 225 minus 64 is 161, so no, that's not it. 8. You got 3, 4, 5, 5, 12, 13, 7, 24, 25. There was an 8 something in there somewhere. 8, what's 8 squared? 64. 12, what's 12 squared? When I add those together, that gives me 208. No. As there's no need to guess, remember, just plug them into Pythagorean theorem. We'll leave that one out there for you. You guys are pretty good in that we got the other ones. While we're here, let's go ahead and remind you of this for next year as well. There's a couple, those are called Pythagorean triples. There's a couple of special triangles. X on the square root of 2 is a, what kind of right triangle? Isosceles. X and X, that's 2 sides. That makes it isosceles. X on the square root of 2. What was the other one? 30, 60, 90. X, 2X, X on the square root of 3. Pretty good right there. We'll stop.